We introduce in this section GARP and GVRP in order to facilitate automation of VLAN-based attributes. In networks with extensive numbers of devices, changes are at times required for certain attributes such as the implementation or removal of a VLAN. The manual configuration of each switch to recognize and support the new attribute may lead to extensive administration and the potential for human error. The Generic Attribute Registration Protocol, or GARP, is used to define the architecture on which attributes can be propagated. The application of GARP, along with GVRP in support of VLAN technology, is introduced as a solution for optimized administration. Upon completion of this section, it is generally expected that trainees will be able to describe the construct and messaging characteristics of GARP, as well as configure GVRP. GARP is effectively a mechanism that supports the registration, deregistration, and propagation of attributes within a network. We can understand attributes to be certain configuration information associated with an entity, such as a switch in the network, that is to be ingrained through a registration process into other entities. The main purpose for this is to reduce the burden generally necessary in sharing such attributes across a number of devices, and so rather than manually configure each device for each attribute, which would be somewhat time-consuming, the devices can be configured to automatically support the registration of attributes, thereby saving the need to manually apply the attributes to each device. GARP is supported through the transmission of protocol data units, or PDUs, that carry the attribute information between devices. The interfaces of devices are referred to as GARP participants, and it is these interfaces that are responsible for generating the GARP PDU that are transmitted to a multicast MAC address, for which other GARP-enabled devices will be listening. Attributes are listed in messages within the PDU and are identified by an attribute type and attribute list that may list one or multiple attributes. Currently, there is only one attribute type, however, and that is GVRP, which we shall take a look at shortly. Each attribute within the attribute list is made up of 3 fields containing the attribute length, which can be anywhere from 2 to 255 bytes, an attribute event, which is represented in the form of join and leave messages, and an attribute value, which, where GVRP is concerned, relates to the VLAN ID. The endmark field is the last field and indicates the end of a GARP PDU. The attribute events of a GARP PDU will determine the mode of operation that is to be applied to the carried attributes. The first of these is the join message, which identifies that an attribute should be registered to a GARP participant that receives the join message. This effectively allows the device interface to learn the attribute dynamically, without requiring manual configuration of the attribute through administrator intervention. These messages will be propagated downstream to allow GARP participants to register the attribute. However, this only represents registration on the receiving GARP participants in what is known as unidirectional registration. While join messages allow for the registration of attributes, it is the leave messages that perform the deregistering of select attributes. The process again relies on the same GARP PDU, but will distinguish the join and leave messages through the attribute type field. We see here again that the attribute removal is propagated in the same manner as the attributes were originally registered. Where it is necessary that all attributes be deregistered, the PDU is generated containing the leave all attribute type. Through this, we effectively are able to remove all of the attributes from the GARP participants that are associated with the sender. Now we have covered the general mechanism of GARP. We are able to apply its operation to the application that it is capable of supporting, which comes down to a single application currently in the form of GARP VLAN Registration Protocol, or GVRP. As an application of GARP, GVRP is used to support the propagation of VLAN information throughout the switching network. The VLAN ID represents the attribute that is propagated, and as we have seen, can be either registered or deregistered to GARP participants. GVRP is required to be enabled on the switches initially, and following which, all adding and removing of VLANs can be performed dynamically. We can demonstrate with VLAN 3 how the VLAN information is propagated throughout the network. In doing so, the switch will create the VLAN, and the receiving interfaces, which should be understood to be the GARP participants, will be associated with the VLAN. The VLAN registration attributes can take on one of 2 forms. The first being static, meaning that it is manually configured on the switch, or dynamic, in which the VLAN has been learnt as a result of propagation of the VLAN attributes through GVRP. In addition to this, we also find that various transmission modes can be applied to the GVRP attributes, for which the registration mode applied influences the effect of how the VLAN types are handled. There are in fact 3 registration modes that may be applied in the forms of normal, fixed, and forbidden. Where the normal registration mode is used, the registration and deregistration of VLANs is supported for both static and dynamic VLANs. We can understand this simply to mean that no restrictions are applied to the VLAN propagation. If the fixed mode is applied to the switch enabled with GVRP, the registration and deregistration of dynamically learned VLANs is restricted, and only the attributes associated with static VLANs will be propagated within the GARP PDU. Where the forbidden mode is applied, the registration of all VLANs that are learned both statically and dynamically will be restricted. This basically limits registration of VLAN attributes to the native VLAN of VLAN 1. The configuration of GVRP involves only a small number of commands that allows GVRP to operate, and also defines the mode of registration that is to be supported. One of the key points to understand when it comes to the configuration of GVRP is that the protocol must initially be enabled within the system view before it is activated on an interface. We can see in the configuration example shown here that along with the configuration of the VLAN trunk between the 2 switches over which all VLANs are permitted to be forwarded, GVRP is also configured on the interface and has been set with a fixed registration mode. The effect of this GVRP registration command means that only those VLANs that have been statically configured will be allowed to be propagated as attributes to other GVRP-enabled switches, regardless of the fact that the trunk allows all VLANs to be forwarded. We can use the display GVRP status command to view and verify the current GVRP configuration parameters that have been set. From this, we are able to determine whether or not GVRP has been enabled initially in the system view, and also which interfaces are actively supporting GVRP, which in this case relates to the Gigabit Ethernet 0/0/1 trunk port interface. Where GVRP PDU are received, the MAC address from which the last PDU was received will be listed. Finally, of course, is the registration mode that is currently assigned, and this is set to a fixed mode, as was configured. In summary for this section then, we just have a couple of questions here. The first asks, what is the default registration mode used by GVRP? Well, the normal registration mode is the mode that is used by default, and what is necessary in order to allow the VLAN information to be propagated over the links between each of the GVRP-capable devices? Well, as we may have noticed from the configuration, it is necessary that the link be configured as a trunk link, as is typically found with any VLAN configuration, in order to support the propagation of VLAN information dynamically using GVRP. This is in addition to the need to enable GVRP on the devices through which dynamic registration of VLAN attributes is to be supported.